In this section, we wrap up our calculus with multivariables, going back to integrals. And it's a good transition because in the next section, we will do integrals again, but back to a single variable. Okay, so we have this double integral here. And sometimes they will write it just as is, the way that I have it written here. And other times they'll put a parenthesis around this first set. Okay, those mean the same thing. Just as a heads up when we're doing this, this integral actually comes first. It tells us, treat x as a constant, integrate with respect to y. So just like we were doing partials, right, we'd treat one of the variables as a constant, do the partial, and then go from there. Same thing here. And the reason we do this one first is because it works like from innermost parentheses to outermost. So although they may not have parentheses, right, we're looking at this integral, I'm going to draw on this other one here, first. And then whatever our result is, we will do with respect to x second. Okay? So again, if there isn't parentheses, that's the order. I'm going to go ahead and throw them in there, though. So we integrate 1/3 y to the third x dy with respect to y. So again, x is some constant, so it's almost like, treat it as the 1/3, right? X over 3. That is all going to stay. So 1/3 x. The integral of y cubed, we've been doing derivatives, so remember integral is we add and divide. Derivative, we bring it down and subtract. It's tempting to bring this 3 down and cancel with 1/3, right? But it's an integral, so it's not true. All right, and we go from -1 to 1. Let's switch colors here. Whatever this result gives us, we will then integrate from 0 to 1 with respect to x. Okay, so wrapping this up, substitute. Well, one thing I suppose I'm going to do is simplify this first a bit. So we have 1/12 x, and then we have y to the fourth from -1 to 1, right? Save a little bit of work. So when I substitute 1, I just have 1 to the fourth, subtract a -1 to the fourth. So negative to the fourth is positive. So I'd have 1 minus 1, and that whole thing is 0. Okay. Well, 0 multiplied by all of this, right? I just have 0 here. 0 multiplied by anything is 0. So I have 0 dx. Switch back to that other color here. And well, to integrate 0, and we still get 0, right? Because 0x and then substitute 1 and 0, we still get 0. Okay, that was a weird one, but it is possible. Okay, we do this integral and we get a 0. Okay, moving to this next example. Integral of e to the x plus y. So we know the integral of e to the x dx is just e to the x. Okay, we're using y as the variable, x is some constant. In the next chapter, we'll really learn about use substitution and doing these integrals with rhyme and reason. But for now, you have seen this before, where if we have some constant up here and then the variable, the integral of that still remains the same. So we still have e to the x plus y. Okay, from 0 to x. And then I'll switch colors here because we're going to do this next, right after we get this result. Okay, so substitute x, we'd have e to the x plus x, or e to the 2x, subtract, substitute 0 in for y, so that would just be e to the x. Now we are integrating that. Okay, integral of e to the 2x. So remember, derivative, we bring that 2 down, and integral, we divide. It's still e to the 2x over 2. Subtract e to the x, all of this from 0 to 1. Substitute 1, we'd have 1/2 e squared minus e to the 1. Okay, that's substitute in the 1. Now substitute 0. So, subtract, my bad. Okay, substitute 0, we'd have e to the 0 over 2, which we know e to the 0 is 1, minus e to the 0, again 1. So this is 1/2, subtract 1, that's a negative 1/2, but then I have a negative out front. So all in all, it becomes positive 1/2. So 1/2 e squared minus e plus 1/2. One way we could write this, if, this answer is perfectly fine, but if you check your work and sometimes they have slightly different answers, they may factor out a 1/2. And in that case, we'd have e squared, but right here we'd have minus 2e, right? Because if we distribute the 1/2 times 2, we'd get 1, and then plus 1.